Today, we're going to dive into the story of a scientist whose name is tied to some of the most, well, mind-bending discoveries in all of modern physics. So what did things like lasers, superconductors, and the super-famous God particle all have in common? It might sound like a bit of a riddle, right? But the answer isn't a thing. It's a person. And his story connects all of these incredible technologies through one single revolutionary idea. That's it. All of them. Lasers, superconductivity, even the Higgs boson are governed by the behavior of a fundamental type of particle called a boson. So you have to ask, who was the Bose that gave his name to the boson? Well, his story doesn't start in some famous European lab with all the latest gear. Nope, it starts in colonial India, with a mind that was about to completely reimagine the universe. Satyendranath Bose was born back in 1894 in Kolkata. And from a really young age, it was clear he had this extraordinary talent for math. I mean, you just couldn't miss it. His academic journey was, well, nothing short of spectacular. He was constantly outperforming everyone around him, eventually getting the top rank in his Master of Science degree. And remember, this was all happening inside a colonial system that really didn't offer a lot of opportunities for Indian scholars. And, this is one of my favorite stories about him. It's almost a legend. A teacher was so blown away by his work that he actually gave him 110 out of 100 on an exam. Why? Because Bose hadn't just solved the problems, he'd solved them in multiple different ways. He wasn't just finding the right answer, he was finding all of them. Okay, so fast forward to 1924. Bose is now a lecturer at the University of Dhaka. And while he's teaching, something is bugging him. A real inconsistency in Planck's radiation law, which was, a huge deal in the new quantum theory. For Bose, the math just wasn't clean. It felt like a shortcut, and that just didn't sit right with him. So he came up with a new way to do the math, and it was based on this truly radical idea. What if particles of light, photons, are all fundamentally identical, like you literally can't tell one from another? He wrote up his paper and sent off to a respected British journal, and the response he got was crickets. Total silence. So what do you do when the establishment just ignores you? Well, if you're S.N. Bose, you take an incredible leap of faith. He decided to just bypass the whole system and send his paper straight to the top, to the most famous scientist on the planet. And get this, he included this incredibly humble but also super confident letter. He basically asked Einstein to take a look and, hey, if you think it's any good, maybe you can help get it published. And the result? It was a home run. Einstein didn't just like it, he immediately saw the genius in it. He translated the entire paper into German himself and got it published with his own glowing recommendation attached. Just wow. In that one single letter, that one act of courage gave birth to what we now call Bose-Einstein statistics. It was a whole new set of rules for the subatomic world. It totally changed quantum mechanics, and later on, the particles that follow these rules, they were named bosons in his honor. So what Bose's work really helped do was define the two fundamental families of particles in the entire universe. You've got fermions, think of them as the loners, like electrons. They make up matter and they need their personal space. But then you have the bosons, they're the socialites. They can all pile into the same state and they're the ones that carry forces.
But here's the thing, Bose was so much more than just a physicist. His intellect and his passions were just incredibly diverse.
I mean, the man was a true polymath. He was a skilled musician who played an instrument called the esraj. He translated Einstein's work to make it more accessible. And he was a passionate patriot who fought to have science taught in his own language, Bengali, because he was so committed to building up his country's scientific future. Okay, so let's get back to the physics for a minute. That wild theory from 1924, it turns out it had another startling prediction tucked away inside it. But it would take literally decades for technology to finally catch up and prove him right again. So the year is 1924. Building on Bose's math, he and Einstein together predict that a totally new, really bizarre state of matter could exist, but only at temperatures incredibly close to absolute zero. Now let's jump way, way forward. It's 1995. Scientists in a lab in Colorado finally figure out how to cool atoms down enough to create that exact state for the very first time. They called it the Bose-Einstein condensate. 71 years. Let that sink in. It took 71 years for experimental physics to actually prove his theory. It's just a stunning testament to how far ahead of his time he really was. So what is this stuff? People often call it the fifth state of matter. It's where millions of individual atoms get so cold they stop acting like individuals and they all start acting in perfect unison, like one giant superatom. The discovery was so huge, it earned a Nobel Prize in 2001 for the scientists who did it, validating Bose's work for the whole world to see.
And here's a really crucial point. Even though Bose himself never got that call from Stockholm for a Nobel Prize, his groundbreaking work was the foundation for at least two of them. One for creating the state of matter he predicted, and another for discovering the particle that literally carries his name, the Higgs boson.
So from now on, every time you hear about the Large Hadron Collider or someone mentions the God particle, you'll know the name behind the boson. His name, S.N. Bose, is forever woven into the very fabric of the cosmos. It's just an amazing story, isn't it? It's this powerful reminder that a world-changing idea can come from anywhere, from anyone under any circumstances. Bose's life shows us that true genius, the kind that can redefine our understanding of everything, well, it truly knows no geography.